All right, so I think this is recording. Let's take a look at these two equations. They want us to solve them. They are rational equations. We see fractions. We see variables in the denominator. And variables in the denominator always give us concern that for some number we might get division by zero. And therefore we have to check our answer or possible answers to see if they satisfy the original equation. And if they don't, we refer to them as extraneous solutions. So let's jump in and tackle number 8. Um, let's start out by factoring that second term. If I look at the first term, this 2x over x minus 1. I'm going to focus my attention on the second term here. And I'm going to factor this denominator. And x squared minus 1 factors to x plus 1 times x minus 1. And on the right-hand side, I'm going to write the number 1 as 1 over 1. So by looking at this denominator, I can see that that's the common denominator I want for every term in this equation. So in this first term, I'm going to multiply by x plus 1 over x plus 1. I'm just multiplying that by the number 1. 1 is called the multiplicative identity because when you multiply by 1, you get the identical thing back. Now, over here with this 1 over 1, I'm going to multiply it by x plus 1 over x plus 1. It's missing a factor of x plus 1, but it's also missing a factor of x minus 1. So now that I have a common denominator, I can clear the fraction. I can clear these denominators. If I multiply both sides of this equation by that common denominator, all these denominators will cancel. And all I'll be left with is the operations in the numerator. So I have 2x times x plus 1. I have x minus 5. And on the right-hand side, I have x plus 1 times x minus 1. But before I go any further, I should be aware that, hey, I just multiplied both sides of this equation by a variable, and that might introduce extraneous solutions because I have variables in my denominator. So when I go to look at my answers, I have to make sure that I would throw out a positive 1 or a negative 1 because they would cause division by 0. All right, so now let's try to get this equation in standard form. It looks like it's a quadratic. We have, let's distribute this 2x to the binomial. We have 2x squared plus 2x plus an x. And when we multiply these guys together, we know that we'll get x squared minus 1. So if I subtract x squared from each side of the equation, if I combine like terms, if I add 1 to each side, I now have this in standard form. And it's easy to see that this does factor to x plus 4 times x minus 1. And this gives us two possible solutions of negative 4 and positive 1. But we have to look back at our notes and think about the original equation and specifically the denominators of the original equation. And we can see that we can't allow x equal 1 to be in the solution set. That this is referred to as an extraneous solution. Well, I should, if I'm abbreviating things, I should at least be partially correct in spelling it. The x equals negative 4 is our only solution. And if you plug that in and get the number on the left-hand side here, it should equal 1. If it doesn't, let me know I've made some arithmetic error in my problem, some sign error, or I combined like terms incorrectly. I've done something silly if that doesn't check. All right, so let's take a look at number 9. On the left-hand side, we see that we have a factor of x minus 4 on the right-hand side, in this first term here, we want to factor this x squared minus 7x plus 12, and that factors to x minus 3 times x minus 4. And then we've got minus. Now, let's slow down a bit. This 3 minus x is the opposite of x minus 3. So I'm going to factor out a negative sign. I'm going to look at this as negative 3 plus x, which you can rewrite those terms. That's just x minus 3. Okay, so I have this minus sign, don't lose it. And then within this fraction, I'm going to move this minus sign up to the numerator, and I'm going to change the order of this addition and write it as x minus 3. All right, so now I want a common denominator of x minus 3 times x minus 4. So this term is missing the x minus 3, and this term is missing the x minus 4. All right, so if I were to multiply every term by this common denominator, all these denominators would cancel, and all I'd have left is just the operations in the numerator. So that's what I'm going to do here. I have x times x minus 3, negative 2x minus a negative 15 times x minus 4. And I'm going to slow down and say, well, okay, I'm going to make some comments now that when I do get a solution to this equation, the solution to this equation will be the same as the solutions to our original equation, except for the fact that this new equation may have extra solutions that satisfy it but don't satisfy the original. If x equals 4 happens to be a solution to this equation, I know I can't put it in my solution set to the original equation because it causes division by 0. And by the same argument, I have to throw out a positive 3. All right, so let's go and find the solution set to this equation. X squared minus 3x, negative 2x. Let's distribute the negative 15 to both terms here. And now, so you got to be careful on this one with sign errors. Now we take the opposite of this binomial. All right, I'm going to collect everything on the left-hand side. So I've got my x squared. If I subtract 15x from each side, I'll have minus 18x. Oh, I didn't combine those like terms right there. So let's back up a second. The 15x take away 2x is 13x. So if I subtract 13x from each side, I'll have minus 16x. And if I add 60 to each side, plus 60. All right, so let's see if I can't shrink this up and get our solution set. I'm still amazed by this software. All right. Whoop. So with this quadratic equation, I could complete the square, will always work. Quadratic formula will always work. But sometimes we can factor this, and in this case, I can see that I can factor it. kind of easier to see how to factor trinomials when the leading coefficient is 1, or at least if it's a prime number. So two numbers that multiply together to give me positive 60, but add together to give me negative 16. So I have possible solutions of positive 10 and positive 6. Neither one of those will cause division by 0, so I'm going to keep both of those in my solution set for the original equation, and we're done. So ask any questions as necessary. I hope this helps, and I will talk to you later. Bye.